Hi, hello everyone. Welcome to chemistry session. So today we are going to discussing about a new topic that is about covalent bond. Already we discussed ionic bond. Ionic bond formed by transfer of electrons from metal atom to non-metal atom. Okay, ionic bond formed by transfer of electrons from metal atom to non-metal atom. Now uh, this is the second type of bond that is covalent bond. Okay, covalent bond. So covalent bond formed by mutual sharing of electrons between the two atoms. Okay, covalent bond formed by mutual sharing of electrons between the two atoms. So who proposed this bond? G.M. Lewis. Okay, G.M. Lewis. G.M. Lewis proposed covalent bond. So covalent bond is nothing but covalent bond formed by mutually sharing electron pair between the two atoms. For example, uh, let us see the formation of F2 molecule. So this is F2 molecule. So let us see how this molecule is formed. So already we know fluorine atomic number 9. So when you write its electronic configuration 1s2, next 2s2, 2p5. Okay, so 1s2, 2s2, 2p5. So fluorine, we can write like that also. We can write 1s2, 2s2, 2p5. So this is K shell, the two are L shells. So in P shell, actually P contains 3 orbitals, we know. So we have 5 electrons, 1, 2, 3, 4, 5. So this is pz orbital is unhybridized pz orbital fluorine, which contains one unhybridized pz orbital. So already we discussed the shape of the orbitals. So already we discussed the shape of the orbitals. So uh, here only one unpaired electron present in the fluorine atom. Only one unpaired electron present in the fluorine atom. So according to Lewis dot symbols, whatever the unpaired electrons present in the valence those only are responsible for the formation of the bond with atoms of other element. So whatever the unpaired electrons we are representing with dot mark. So from that what we can understand, if you take any fluorine atom which contains one unpaired electron, so this is the first fluorine atom. If you take we can put the whatever the unpaired electrons in the fluorine atom, we can write like this. So if you take another fluorine atom, okay, so same like it contains also one electron here. Okay, here this is the first fluorine atom, this is the second fluorine atom. Both they contain one unpaired electron. Now both the electrons they are sharing between the two atoms, resulting forms a single covalent bond between the two fluorine atoms. Okay, resulting a single covalent bond formed between the two atoms. So this is an example for covalent bond. Once again, I will recapitulate. So covalent bond formed by mutual sharing of electron. So see here, fluorine. This is the first fluorine electron. This is the second fluorine electron. The two electrons equally shared by both the atoms. So resulting a single covalent bond formed between the two atoms. Generally, covalent bond we are representing with representing in a solid line, but whereas there is no special indications or there is no special notation to represent with the ionic bond. Okay, uh, so this is about covalent bond. So let us see some more examples. In the same way, we know the formation of O2 molecule. O2 molecule. So oxygen molecule. Let us see. Oxygen molecule. So oxygen atomic number 8. So when you write its electronic configuration 1s2, 2s2, 2p4, 2p4. See here. So valence shell of oxygen contains in p orbital one symbol. Okay, whatever the unpaired electrons we are writing around the symbol of an atom. We are writing around the symbol of an atom. Okay, these two represents, these two dots represents. Okay, for better understanding, I am writing cross mark. These two cross mark represent two unpaired electron. Okay, this okay, these two dots represents lone pair of electrons. Okay, so if you take oxygen atom, when you write its electronic configuration 1s2, 2s2, 2p4 in its valence shell, so it contains two unpaired electrons. The two unpaired electrons I am representing with cross mark. Whatever the lone pair electrons I represent with dots. So this is the phenomenon takes place in one oxygen atom. In the same way, if you take other oxygen atom, same like in every oxygen atom, one lone pair, one lone pair, two bond pairs, or lone pair, unpaired electrons. Okay, one lone pair and two unpaired electrons. Don't confuse it. So, for example, see here in p orbital we have electrons like this. Okay. So these two electrons we are call it as lone pair. What we are call it as lone pair. Lone pair. What about this single electrons? This we are call it as unpaired electrons, unshared pair or unpaired electrons. Okay. So in oxygen atom, when you write its electronic configuration, one in its valence shell, one lone pair is there and two unpaired electrons are there. So these two unpaired electrons which are shared between the two oxygen atom, they are forming two covalent bonds between the two oxygen atoms. Two covalent bonds between the two oxygen atoms. So resulting forms O2 molecule. What is that? O2 molecule. In the same way, let us see formation of a methane molecule. Formation of methane molecule. Methane formula CH4. Okay, CH4, carbon atomic number 6. So 1s2, 2s2, 2s2, 2p2. So how many electrons are there? Totally 4 electrons are there. And one more thing is hydrogen atomic number 1. When you write its electron configuration 1s1. So we have to see the valence shell. How many number of electrons are there in a carbon valence shell? 4. Okay, in hydrogen only 1. So we can write the Lewis dot symbol of carbon like this. Means around the carbon we have to keep 4 dots. Okay, here one hydrogen atom contribute 1 electron to form a covalent bond between one carbon atom and one hydrogen atom. So here we have to take 4 hydrogen atoms. So 4 hydrogen atom means generally when you write the Lewis dot symbol of hydrogen, you are writing like this, like this, like this, like this. So here means have you understood? This is the electron pair which is shared by both the atoms. Means it is shared by carbon and shared by hydrogen. Like that, it forms 4 single covalent bonds with 4 hydrogen atoms. So this is the formation of methane molecule. This is the formation of methane molecule. Next, let us see how N2 molecule forms. N2 molecule. Nitrogen atomic number 7. When you write its electronic configuration 1s2, 2s2, 2p3. So in its valency shell, see how many unpaired electrons are there? 1, 2, 3. Okay, and one lone pair, whatever it may be, we can represent like this: one lone pair, okay, and 3 unpaired electrons. In the same way, if you take other nitrogen atom, same like one lone pair and 3 unpaired. So here 3 pairs of electrons which are shared by both the atoms, resulting N triple bond N, means where between the two nitrogen atoms 3 single covalent bonds are formed. Okay, whatever it may be, 3 single covalent bonds are formed. How they are formed? Each nitrogen atom contributing 3 electrons. So how they are formed? Each nitrogen atom contributing 3 electrons. So that 3 pairs which are shared by the both the atoms, resulting 3 single covalent bonds are formed. In the same way, next, formation of ammonia. So already we discussed just now, nitrogen in its valence shell, one lone pair and 3 unpaired electrons. So we can write like this: one lone pair and 3 unpaired electrons. So already we discussed hydrogen atomic number 1. Okay, it's Lewis dot symbol, hydrogen dot. So here one hydrogen atom contribute one electron. So that's why 3 hydrogen atoms which are come in contact with nitrogen atom. So like this: 1, 2, 3. So for better understanding, we can write like this: one nitrogen atom and 3 hydrogen atoms. So we can write NH3. Have you understood? One nitrogen atom, it can contribute 3 electrons. So to receive that 3 electrons, here 3 hydrogen atoms which are donating not, they are sharing their 3 electrons with a nitrogen atom. So finally forms NH3, ammonia molecule. Okay. In the same way, we can discuss with water also. See water formula H2O, how it is formed. So oxygen atomic number 8, so 1s2, 2s2, 2p4. So in its valence shell, 1, 2, 3, 4. So 2 unpaired electrons are there, 1 lone pair is there. Okay, so already we discussed the hydrogen atomic number 1. So when you write its Lewis dot symbol oxygen, we can write like this: one is lone pair and 2 unpaired electrons. In the same way, hydrogen, when you write its Lewis dot symbol like this. So here one oxygen atom contribute 2 electrons, means one oxygen atom sharing its 2 electron with other atoms of elements. Here one hydrogen atom, it can share it 1 electron. So that's why one oxygen atom contribute that 2 unpaired electrons with 2 hydrogen atoms. The same way, hydrogen atoms also, they share the electron with oxygen atom. They forms two single covalent bonds with oxygen. Means here whatever the 2 OH bonds, we can say those are 2 single covalent bonds. Okay, so this is about formation of covalent